Morning, seniors. Shop teacher chief here, pre-dawn hours. Got myself in early. Continue our chief talks about aluminum welding, inverters, transformers, welding technology, electricity, AC currents, and so forth. What I'd like to start out with this lesson is you have reactive metals such as titanium and stainless steel, and then you have non-reactive metals such as aluminum, steel, bronze, copper, so forth. So what I want you to think about is developing a solid baseline of knowledge and understanding of the difference between a transformer and an inverter technology. And when you go into the workforce, when you go into a shop, you have a good baseline of knowledge to set the machine up and to have the right tungsten selection, the right filler wire, the AWS classification of tungstens and electrodes and filler wires. But I'd like to sort of circle back again. I know we talked about this once before. Sometimes you get not a clear understanding. If you pick a wire up and it feels like it's aluminum and it might be stainless steel, there is an old technique that was taught many years ago to me. Take your fingers, and if you have a difficult time bending that wire is most likely stainless steel, which looks like aluminum. And if you have aluminum wire, you can actually bend it pretty well, okay? So that's just an approach or technique that I've used over the years, and I'd like to pass that along. As we continue on in aluminum, this will be your aluminum project that we'll do. We are gonna continue doing other fabrication projects with blueprints, but I'd like to begin with our base knowledge of high frequency, balance, penetration, and hertz. So we know that the electricity coming from the power plant, the electricity coming out of the wall is AC current. And if we're welding aluminum and magnesium, we're in an AC current mode, whether it's on a transformer or an inverter. But I'd like to continue to think about, as you're learning, perhaps you use your notebook. You've got sketching every day, our lessons, our technical information that the chief delivers in your QODs every morning. So please continue to develop your notebooks and making sketches and making notes. This will be an asset later on in your life as you go in and you become a welder, fabricator, sheet metal worker, whatever it might be. You always have a notebook in your toolbox, and you can always refer back to that notebook. So with that said, if you're looking at aluminum, so the aluminum, we've actually realized that aluminum is not as difficult to weld as we thought. But the fundamentals have never changed in a transformer and an inverter, and we'll talk about that. What I really need to talk about is the sine wave. The sine wave is the current of AC electricity. We know that we're on the top is positive for cleaning. We know on the bottom is negative for penetration. We know that straight line going across, when the sine comes up and down on a slope, the arc extinguishes, and that's what our high frequency allows us to continue. We know that we start out with sine wave, old school transformer technologies, which is still out there. You will still come in contact with those machines. That's why your program continues to keep those machines, but you